Welcome to Chapter 8, Lesson 7, Exponential Functions, otherwise known as graphing with exponents. Perhaps you've heard of people talking about exponential growth, or maybe of something getting worse exponentially. Today you're going to learn what people mean when they say such things. Your book begins this chapter with a cartoon where a woman at a party tells a party guest his knowledge is doubling every 10 years and it's making him jumpy. Now, I don't have the picture for you. You might actually have to open your book to see it, but I do want to kind of give you an idea of what that would look like if you were filling out a table for it. If you were talking about time in decades, a decade is, of course, 10 years, then before someone is 10 years old, let's say they have a knowledge of 1. Okay, that means when they're 10, or that next decade, they would have a knowledge that was twice that, which would be 2. After 2 decades, they would have a knowledge of 4, and after 3 decades, they would have a knowledge of 8, and so on. Now, you could also write that knowledge y as powers of 2. Okay, so 2 to the 0 would be equal to 1, 2 to the 1 is equal to 2, 2 squared is equal to 4, and 2 cubed is equal to 8. And so we're doubling from 1 to 2, from 2 to 4, from 4 to 8. But we're showing it with exponents and the number 2. Okay, now because of that, we could write it in this formula: y equals 2 to the x power. So again, I'm just showing you what that would look like, but I'm also showing you, which doesn't make sense logically, but your book does this too, is if you could go back in time. Okay, maybe they weren't talking about when the person was, their first years of life, when they were talking about knowledge doubling. But if you actually went backwards, then you could have negative exponents, okay? So a year beforehand, they would have had 2 to the negative 1, or half the knowledge, right? Because 2 to the negative 1 is half the knowledge. Another decade earlier, they would have had 2 to the negative 2, which would be a quarter of the knowledge that they had. And then negative third would be 2 to the negative 3, or 1 over 8, which would be an eighth. Okay, now I wrote it all out for you because I'm just nice like that, but that just kind of gives you a picture of what an exponential function looks like. Things are not moving up by 1 or 2, okay, but as x gets bigger by 1 or 2, y is getting exponentially larger. Okay, if I graphed it, this is what the exponential graph would look like, and I added a few so that you could see that as x got to the 3, and as x got to the 4, and then x got to the 5, it's going way up there. And that is an exponential graph and what it looks like. Now, the formula for an exponential function, as it is called, is y equals a times b to the x. Now, in the formula that we just talked about the person doubling their knowledge, we are referring to, instead of ab to the x, our a would be 1, our b is the 2, and of course x is just the exponent, so it's referring to the decades. Okay, but it is in that form, but a is definitely 1. Okay, if you have, like you will in your book when you get to your homework, have y equals 6,000 times 0.75 to the x, okay, that's actually part of a word problem in your book. Okay, but your a in that case would be 6,000, and your b would be the 0.75. Okay, and the word problem actually reads, if an automobile worth $6,000 depreciates by 1/4 its value each year, its value after X years is given by this formula. Okay, so you'll actually be doing some work with it, but I wouldn't want to give away those answers now, would I? Let's say we had a formula that looked like this, where our a is 4 and our b is 2, and we're raising it to the x exponent. Okay, so if we had, let's say, x was negative 2, then we would have to apply a lot of things about our laws and rules of exponents, okay? So we would really be thinking 4 times 2 to the negative 2, or 4 times 1 over 2 squared, or 4 times 1 over 4, which equals 1. Okay, so in this formula, when x is negative 2, y actually equals 1. Okay, now in the next one, and you see all this work I'm putting here, I'd like to see evidence of that on your paper. In other words, don't do it on scratch paper, and don't do it in your head, and certainly don't use a calculator. All right, so the next problem I would set up is 4 times 2 to the negative 1. And we all know that 2 to the negative 1 is 1 over 2, so it's 4 times a half, which of course equals 2. The easiest exponent you'll ever run into is 0, because when we run into 0, we know it's 4 times 2 to the 0, or 4 times 1, which is simply 4. Okay, and if our exponent is 1, then we're going to have 4 times 2 to the 1, or simply 4 times 2, which equals 8. And if we have 4 times 2 squared, it's 4 times 4, which equals 16. So we're going from 1 to 2, 2 to 4, 4 to 8, and 8 to 16. That is an exponential function. And as long as you continue using the rules and the laws that you've learned on exponents, you should have no problem drawing those little graphs. Have fun!